Welcome to today's investigation. Lightning, how a simple updraft becomes a powerful charge. Have you ever heard thunder and counted the seconds until the boom? Or seen a lightning bolt streak across the sky and wondered, how does that even happen? Today, we're unlocking the science behind lightning, from how thunderstorms build up to the exact moment that electricity zaps through the sky. It's shocking, powerful, and all part of nature's energy cycle. Let's explore. Every lightning bolt begins with a thunderstorm. And every thunderstorm starts when warm, moist air near the ground begins to rise. As it rises, it cools and condenses into clouds, first cumulus, then building into towering cumulonimbus clouds. These clouds can grow up to 12 kilometers tall. As the storm matures, powerful winds toss ice, water, and tiny hailstones around, and that's when something amazing happens. All that movement causes particles to collide, and these collisions separate electric charges. Heavier Graupel particles usually become negatively charged and sink to the bottom of the cloud. Lighter ice crystals take on a positive charge and float to the top. This creates a massive electrical imbalance in the sky. Meanwhile, the negative charge at the bottom of the cloud pushes away electrons on the ground, causing the ground itself to become positively charged, especially on tall objects like trees, buildings, and even people. Now, the stage is set for a lightning strike. Before lightning strikes, something invisible happens first. A tiny channel of ionized air called a stepped leader begins zigzagging its way downward from the cloud. It travels in steps of about 50 to 100 meters, searching for a path to connect with the ground. At the same time, the ground sends out positive streamers, tiny tendrils of energy reaching upward to meet the leader. When one finally connects, boom, the electrical circuit is complete and a massive surge of energy flows upward in a split second. That's the flash of lightning we see. When lightning strikes, it heats the surrounding air to over 30,000 degrees Celsius, 5 times hotter than the surface of the sun. This sudden heat causes the air to expand explosively, creating a shockwave that we hear as thunder. Because light travels faster than sound, you see the lightning first and hear the thunder a few seconds later.